Okay, Assalamualaikum warahmatullahi wabarakatuh. This video, I'm going to discuss on chapter 2 for code CHM361 in organic chemistry with a subtopic chapter molecular orbital theory. In this chapter, we're going to discuss first type of molecular orbitals, and then we're going to look into homonuclear diatomic molecules for element in second period in periodic tables, and then in energy level diagram, and also the electron configurations for the diatomic molecule, and lastly to calculate the bond order. So at the end of this chapter, you should be able to first explain the molecular orbital theory, and then next you should be able to draw molecular orbital diagrams. Then from there you need to be able to identify the magnetism properties of the molecule. You should be able to calculate the bond order, and lastly to identify the bonds and the existence of the molecule. Okay, first, molecular orbital theory. So this theory describes the covalent bonds in terms of molecular orbital. Before this, in chapter 1, we describe the covalent bonds in terms of atomic orbitals. Okay, so in this theory, this result from interaction of atomic orbitals of the bonding atoms and are associated with the entire molecules. Okay, so what's the difference between molecular orbital theory with atomic orbital theory? So in atomic orbital theory or atomic orbital, it's only associated with only one atom. As you remember, before this we only focus at the central atoms only. So this theory actually arises from a fundamental differentiation in BBT, valence bond theory. So they have some late differentiation on this theory. So the scientists come out with this new molecular orbital theory, and it can be said that in molecular orbital theory, the atomic orbital will overlaps with atomic orbital to form the new molecular orbitals. So the molecular orbitals have shapes and energy levels that are different from those of atomic orbital. Okay, before the atomic orbitals, we learned that they have one s. Okay, and then you have p with 3 orbitals with different axes. Okay, x, y, z. Okay, so they're different. And then the electrons in molecular orbitals are delocalized throughout the orbital. Means that the electrons in molecular orbital is delocalized, means it's moving around throughout the orbitals. Okay, before this we know that in atomic orbitals the electron will only be in the orbitals. Okay, localized in these orbitals only, but for molecular orbitals it say that it delocalized throughout the orbital, and the overlap of two similar orbital will lead to formation of two molecular orbital, which is bonding molecular orbitals and anti-bonding molecular orbitals. So what is different between these two molecular orbitals? First, we're going to look and discuss on bonding molecular orbital. Okay, so in bonding molecular orbital, the molecular orbital that has lower energy and greater stability with than the atomic orbital from which it was formed. Okay, let's say you have s orbital, then you overlap with s orbital. So this is energy. Okay, contohnya dekat sini lah orbital awak. So when they overlap, so for bonding orbital, it form lower energy and greater stability than the atomic orbital itself. So bila dia overlap, so energy dia akan turun lower. So the new orbital yang overlap tu, dia punya energy is lower than the original, dan dia punya stability pun lagi stable compared to original. So in bonding molecular orbital, so the electron density is greatest between the nuclei of the bonding. Contohlah ada bonding, okay, ada bonding. So electrons density is dekat between the nuclei. And then when we placing electron in bonding molecular orbital, it yield a stable covalent bonding. So means that when we have electrons, okay, placing in this bonding molecular orbital, so the covalent bondings it become stable. So it's good. Okay. So it's also known as constructive interference. Okay, means that increase in amplitude is analogous to the build-up of electron density between two nuclei. So bila this is constructive interference, so the amplitude will be increased. Okay, we can say that the density, electron density between the two nuclei is here. Okay, so what is different between bonding molecular orbital with anti-bonding? So the difference is that kalau bonding tadi dia lower energy, but while in anti-bonding we have higher energy and lower stability from the original atomic orbital. So tadi contoh ada dua orbital, bila overlap, kalau bonding tadi dia lower energy, so dia jadi bonding orbital. So this one bila overlap dia akan jadi anti-bonding. Okay, higher in energy, while the electron density decrease to zero between the nuclei. So kalau tadi dia ada dekat between the nuclei, so sekarang nuclei dekat sini, so electron dia is away from each other. So dekat sini tak ada electron density, decrease to zero. And then while you placing the electron in this antibonding molecular orbital, it will result in unstable covalent bonding. Okay. So kalau tadi bonding we call as a constructive interference, for antibonding we call as also known as destructive interference, which is a decrease in amplitude is analogous to the decrease in electron density between two nuclei. So bila this the difference wave kat sini, so become destructive, so they cancel out lah. So maknanya no electron density between the nucleus.